Now, let us discuss the resultant of several coplanar concurrent forces. There are basically two methods by which we can find out this. One is a graphical method, and the second one is the analytical methods. In the graphical method, as we have discussed in the previous video, that we apply the law of triangle law or parallelogram law or polygon law. Okay, any of these law, we basically draw all these forces according to the scale and find out the resultant and its direction. In the analytical method, we will go for the principle of resolved parts. So as we discussed previously also, that we can find out the components of all the forces in the horizontal direction and in the vertical direction, sum these up in horizontal components separately and vertical components separately, and even we can find out the angle of the resultant by using these equations, like a resultant, the horizontal component of the resultant will be equal to the sum of all the horizontal components of all the forces, say in this case P1, P2, P3 and the three forces. Similarly, the vertical component of the resultant is given by the sum of all the vertical components of all the three forces in this case. And if there are more number of forces, we can go ahead and add all these forces components, and the total resultant, the numerical value we can find out by taking r is equal to square root of the horizontal component square plus vertical component square of the resultant, and the subtending angle of the which we notate with the angle theta of the resultant with the horizontal is given by the tan theta of vertical component divided by the horizontal component. That is very easy to find out. So um, let us go with the first example, which is the solved example given over here. The statement is like that: find the magnitude and direction of the resultant of two forces, 40 Newton and 60 Newton, acting at a point within an included angle of 40 degree between them. The force of 60 Newton being horizontal. So this is given, and angle is given. We can simply apply the formula which we have discussed um, in the first formula of problem solution, solving the problem. That means that is r is equal to p square plus q square plus 2 pq cos theta, and this is given over here. The answer is 94.22 in this case after solving. And tangent of the resultant force with the horizontal is tan alpha is equal to q sine theta divided by p plus q cos theta, which is q is 40 here and p is 60, so you get 15.85 in this case, as the direction of the resultant force as well as magnitude of both are formed. Coming on to the next example, which is 2.2, the angle between the two forces of magnitude 20 Newton and 50 Newton is 60 degree. The 20 Newton force being horizontal, determine the resultant in magnitude and direction if the forces are pulls. That means both the forces going in the similar direction. That means pointing outwards from the origin, like this. So this is the 20 Newton force, and you have this. Sorry, this figure is not representing the first part. The first part is easy. The angle is given again. You can apply the same formula: p square plus q square plus 2pq cos theta. The angle is given to be 60, and this we can simply find out over here, and similarly we can find out the angle. So now in the second case, the 15 Newton force is the push force. It is mentioned to be push force now, whereas 20 Newton force is considered to be again a pull force. So this is pulling in this direction, in the horizontal direction, and the 15 Newton force becomes the direction becomes opposite. That is a pushing. Pushing means pointing towards the point. Okay, from where this 20 Newton force is originating. So in this, the you will have to remember when you are solving this kind of problem with this parallelogram law, which we discussed at the first instance. Let me take you to that formula. Okay, so this is a parallelogram law. The forces are pointing, both the forces are pointing out of the outwards direction. That means this p force as well as q force, and this angle is a included angle, which is the angle theta. Whereas in case of triangle, one force is in this direction and the second force starts from the end of the first and goes in the same direction. So this is the difference between the two. When you are applying this triangle law or parallelogram law, you have to take care of this. So let me go again to the problem 2.2, second part. So this angle now becomes 120 degree. Okay, so this is the resultant. That means 20 square plus 15 square plus 2 into 20 into 15 cos 120, and this is the tan angle, tan alpha, which is the angle with the, or alternatively, if you are not comfortable, you can take the angle to be like this, starting in the clockwise direction. Okay, so if so you can choose um, one of the, you can say, sign conventions when you are dealing with the angles and directions. Okay, so it doesn't matter, the answer will remain the same. Okay, so